Okay, this is lesson number 6 on tree diagrams. Tree diagrams, two situations, with replacement and without replacement. Tree diagrams are very useful for showing outcomes of multiple events. A weighted tree diagram has the probabilities on the branches. Tree diagrams can be used to help solve problems involving both dependent and independent events. In the following situation, Peter has 10 cubes in the bag, 3 are red, 7 are blue. Moves a cube at random from the bag and notes the colour before replacing it. Record the following information on the tree diagram. So we set it up like this. His first choice, he can pick a red or a blue. Then the chances of getting a red are 3 out of 10, because there's 3 red and 10 in total. So it's 7 out of 10 for blue. You'll note that those two things have to add up to 1. Represents everything can happen. After you've done your first choice, then your second choice, you could choose a red or a blue, but depending on what you got on the first one. The chances of getting a red again are still 3 out of 10 because the cube was replaced. Blue still 7 out of 10, etc. To work out the probability of getting each of these possibilities, and the 4 possibilities there is red then red, red then blue, blue then red, blue then blue. You multiply along the branches. So red is 3 out of 10 times 3 out of 10 is 9 on 100. Red blue, 21 on 100. Blue red, 21 on 100. Same result as red blue, the order's different. And blue would be 49 out of 100. Few things to note. The end of the first and second will show the different outcomes. The probabilities for each event along the arm of each branch, they sum to 1, as I said before. And also, well, the probabilities are multiplied along the branches. And the last thing, these 4 probabilities here will add up to a whole, 100 out of 100 in this case. This one here, Rebecca has 9 coloured beads and 4 are black, the rest are green. So let's set up a tree diagram for this. So it's all been done. And you see, go black or green, the choices. Multiply along the branches. There was 4 black and 5 greens. That's why those probabilities are like that. Once again, probabilities add up to 1 at each branch. And if I add up these 4 probabilities, I'll add up to 81 out of 81. Calculate the probability that the 2 green beads is this pathway down here, so it'd be 25 out of 1. Find the probability of black followed by green, so black followed by green, 20 out of 81. 2 coins, Peter's tossing 2 coins, so the tree diagram would look like this, head or tail, then you can get another head and tail, or a head and another tail. Multiply along the branches, so asked here the probability of 2 heads would be 1/4. Probability of a head or a tail in any order, so it's that plus that. 2 heads, 1/4. Probability of a head and a tail, or a tail and a head, you have to add up both those. So if 2 or more combinations have to be considered, you add them together. So 1/4 plus 1/4 is a half. You'll note at the end here, all 4 of those add up to a whole still. Okay, let's read this one. Peter and Becky run a race and play a tennis match. The probability that Peter wins the race is 0.4. So on the race, Peter wins or Becky wins, 0.4. So this would have to be 0.6 here. And the probability that Becky wins at tennis is 0.7, so the chance of Peter winning is 0.3. So we add those to the branches. What's the probability Peter wins both of the events? Well, that's this pathway, so it'd be 0.4 times 0.3. So the answer would be 0.12. Probably Becky loses the race, that means Peter wins, but wins at tennis. So the pathway is Peter win, Becky win, so it'd be 0.4 times 0.7 is 0.28. Two things to note with this tree diagram. Those two probabilities there add up to 0.4 as the original split. Those two probabilities there add up to 0.6, the original split here. All four probabilities still add up to 1. Each split, you'll see the probabilities add up to 1. There's those answers. With replacement. Coins tossed 3 times. Now on your note booklet, it's this example. There's a tree diagram. If we toss the coin 3 times, 8 different outcomes, 2 by 2 by 2. Each outcome is equally likely. Probability of 3 heads would be 1 out of 8. Probability of 2 heads, I can do that 3 different ways. I can go head, head, tail, or head, tail, head, or tail, head, head. So there's 3 out of 8. The coin is tossed, then a die is rolled. Draw the tree diagram, complete in your notes. So 2 things can happen on the toss of the coin, 6 things with the die. So they're the questions we're going to answer. So we fill in the tree diagram. What's the probability of tossing a head then rolling a 5? Well, that's the pathway going head, then 5. That's 1 out of these 12 outcomes. 12 outcomes, 2 by 6. 2 by 6 gives me 12 outcomes. So that's 1/12. Tossing a tail, then rolling an even, or tail, but there's 3 evens on this branch. So it'd be 3 out of 12, which is 1/4. Tossing a tail, then rolling a 7. Well, there's no 7, so it's impossible. So the probability is 0. Consider this tree diagram. Selecting red, maybe from 2 different bags. The first bag there's 2 reds and 1 blue. Second bag there's 1 red and 3 blue. So you take 1 from each bag. This is the possible results. What's the probability of drawing 2 reds? So it's this pathway along here, 2/3 times 1/4 makes 1/6. Drawing a red then a blue, it's this pathway, so it's 2/3 times 3/4, which is a half. Drawing 2 blues is the bottom pathway, 1/3 times 3/4 is 1/4. Drawing no blues is the same as drawing 2 reds, so it'd be the same as answer to A. And drawing 1 blue, well, I can do it this way, or I can do it this way. If you use the word or, you add the answers at the end. So it can be done 2 ways, red blue or blue red. So that'd be 2/3 times 3/4 and 1/3 times 1/4 equals 2 7/12. Now we're going to look at dependent events. It means we sample but don't put the thing back in. So first choice, red or blue. Second choice, the probabilities are 3/10 and 7/10. Second choice, you can get a red or a blue depending on what happened first. But if I get a red the first time and don't replace it, then there's only 2 reds left out of 9. There'll still be 7 blues out of the remaining 9. If I take a blue out first, there's still 3 reds out of the 9, but now only 6 blues out of the remaining 9. Multiply along the branches. And if we added up these probabilities here, they'd add up to 90 out of 90. This one, Rebecca has 9 colours, 4 are black and the rest are green. She moves a bead around from the bag and does not replace it. She then chooses a second bead. So we asked to draw a tree diagram and answer some questions. So here's the tree diagram. Asked to calculate 2 greens, so it's pathway here. There were 4 black and 5 green. She chooses a green first, then the second time there's only 4 greens left out of the remaining 8. So that's that answer there. A black followed by a green, so black followed by a green, so it's 4 9s times 5 8s. With replacement, in your notes there's these examples. Family have 3 children. What's the probability of a few questions there? So we draw a tree diagram first. So a bit more with replacement. So tree diagram will look like this. Probability are all boys. It's like our one before 3 heads. So it'd be 1/8. First is a boy, second and third is a girl. Very specific order. It's only that pathway can happen. So it's 1 out of 8. 1 is a boy and 2 are girls. 1 boy, 2 girls. 1 boy, 2 girls along that pathway, and 1 boy, 2 girls along that pathway. Order's not specified, so we add the 3 probabilities together. They are not all boys. So there's one way out of 8 where they're all boys. So the remaining 7 all contain at least 1 girl, or 2 girls, or 3 girls. So the best way to work that, probably not all boys, is to say it's 1 everything minus the probability of all boys. 1 minus 1/8 equals 7/8. Or in this case you could add up that you see there's 7 different ways, not all boys. In this one here, mathematics students calculates his chance of passing the next test according to the results on early tests. If he passed the last test, he thinks his chances are 0.7 of passing the next test. If he failed the last test, he estimates the probability of passing the next test is 0.5. Draw a probability tree diagram to illustrate the possible results obtained in the next 2 tests, given that he failed the previous test. So we start off, you can pass or fail, pass or fail. Key information is he failed at the start. So first one we can put in there, because it says here, if he passed the last test, he thinks his chances of passing the next test are 0.7. I was just going to get the highlighter there. So if he passed, hang on. So say here, if he passed, he thinks his chances are 0.7 of passing the next. So that's why we put the 0.7 there. If he failed the last test, then the chance of passing is 0.5. Good idea when you do probability questions is to highlight the important information. So fail, then pass, 0.5. So that fail, then pass, but also over here we can put the same thing. Alright, we can complete the tree diagram. If it's 0.5 there, then it has to be 0.5 there. If it's 0.7 there, it has to be 0.3 there, and likewise 0.5 there, 0.5 there. Let's answer the question. Passing both, be this pathway, pass, pass. So it'll be 0.5 times 0.7 is 0.35. Second question, pass the first but not the second, so that's this pathway. Third one says fail the first, pass the second, so that's that pathway. Fail then pass, 0.25. And fail both is the bottom pathway, 0.5 times 0.5. Third example, here we've got a situation, an urn is like a vase, so we've got 7 blue and 3 red, and 2 are taken around them. We can do this 2 ways. We can take one out and replace, or we don't replace. So we've got 2 different situations. So, and we're asked several questions here. Let's do the tree diagram. With replacement, blue and red, there's 7 blue and 3 red. With replacement, there'll still be 7 blues and 3 reds in each case. Without replacement, we go blue, red, 7 blue and 3 reds to start with. But if I choose a blue and don't replace it, then there's only 6 remaining, but still 3 reds. If I choose a red, then there'll still be 7 blues and only 2 reds. So there are our tree diagrams for the 2 situations. We're asked to work out these probabilities for each situation. So the probability both balls are blue. So this is for with replacement, 7 out of 10 times 7 out of 10, so it'd be 49 out of 100. Next one says the first is red, the second is blue. First is red, second is blue, is that pathway. So it's 3/10 times 7/10, It's 21 out of 100. And the last one says 1 is red, 1 is blue. So I can actually go this pathway or this pathway. So I have to add those two probabilities together. So it's 3, I've got 3 tenths times 7 tenths, or 7 tenths times 3 tenths. That's what's here, and that equals 42 out of 100. If I do it without replacement, the first one here, 2 blues, is 7, and there's a 6 covered up there. So 7 out of 10, then 6 out of 9, because the ball hasn't been replaced. Next one, red, blue, is this pathway. So it's 3 out of 10 times 7 out of 9. And the last one, we've got to do the two pathways, that pathway and that pathway. So it'd be 7 out of 10 times 3 ninths, and 3 out of 10 times 7 ninths. And we get that answer 42 out of 90. So you'll notice the probabilities, same questions, but because with replacement without replacement, we get slightly different probabilities as answers. Okay, this is the questions you need to do for this topic. Good luck. Thank you.